Hi everyone, my name is Kudus Makara. This is the Andrick State Wildlife Area Project. Including me in this team are Matthew Cash, Ashley Pearson, Jessica Hernandez, Sarah Ibrahim, and Nick Maleski. Before the 1800s, there was no regulation whatsoever on wildlife activity. So this was taking a toll on wildlife habitat. To mitigate the issue, the state has created agencies and implemented regulations to control these activities. Now, in 2011, the Colorado Parks and Wildlife was born, and this new agency is now in charge of operating the state park system by providing all outdoor recreational activities. They do this by educating people on practices of fishing and hunting, and through this, they are able to issue hunting and fishing licenses to eligible residents, which then allow them to control those activities. Now, the agency oversees 41 state parks and more than 350 wildlife areas. And Andrick State Wildlife Area is just one of those areas. It is 710 acres and is known for providing recreational hunting services and mostly managing waterfowl habitat. Now, the area is located here in Colorado, in Orchard. It's a little over 1 hour drive from downtown Denver, going eastbound. That's on the west side of Morgan County. We are working with this agency today because for the past couple of years, they've noticed an increase in the cost of management and maintenance of the area. Upon investigation, a conclusion was made that it was mostly due to equipment management, hauling in and out equipment from far away distance. Now, that's where we come in because our goal here is to reduce this overall cost of management by building a 30 by 60 foot structure to allow the crew to store equipment needed right there on the site. We started this way by meeting with Mr. David Kaufman, who is a representative of the agency, and the purpose of their meeting was to get a better understanding of the scope of work. Thank you.
During our meeting, we discussed with the client the requirement for the building, and what we got is the dimensions to be width of 30 feet and a length of 60 feet. Also, the client have requested different features such as a tool room, an office, and a restroom, and a loft. We've also requested a 3 garage with a height of 16 foot and a wall height to be 18 foot. Also an exterior carport with 15 by 60 feet in length. They also requested a couple of features for the structure to hold a heavy equipment, small heavy equipment such as small loader and excavator. And then next slide, please.
So this is our site layout location. So we're north of Colorado Highway 144, approximately 2,000 feet west of Jackson Reservoir. You see the top call out there, that's the site location. A blow up of that is the small map here, which roughly has where the building will go, boxed in there in red. So we have power out to the location from an old hunting lodge. Water service is not in the area, so we're suggesting to build a well. The closest water is about 2,000 feet away. And then there's no sewage service there, so we're going to be designing a septic disposal system. Next slide. This is going to be the building's orientation. It'll be 150 feet west of the eastern property line, and it will be roughly 160 feet south of County Road AA. So you can see it's oriented north to south, with the overhang being on the east side and 2 garage doors being on the west side and 1 garage door on the south. Next.
So I'm Matt, and I will take you through the start of the beginnings of the structural design. The materials used in the building are timber, steel, and concrete, with timber being overwhelmingly the material used the most. The loads, as you can see on the screen here, that this structure has to withstand are basically your equipment loads, your gravity loads, and the loads nature is going to put on this structure. So essentially our task is to build a storage building that's going to withstand whatever Colorado can throw at it. And to do that, the first thing we had to design was the framing system. So we had two options. We had a traditional stick frame system and a pole barn system to choose between. Upon analysis, it was concluded that the pole barn was going to be cheaper because it uses less material overall, but that would also be weaker and less durable. So the team recommends doing the traditional stick frame to get that durability back and thus let this structure function for many years to come.
I'm Ashley, and I'll be walking you through the soils report as well as some of the structural pieces of the structure. So in order to design an adequate foundation, we needed a soils report, which would eventually be provided by the client. In this report, we learned the soil type as well as the soil bearing pressure, which was 1,500 pounds per square foot. This was the number that would be utilized to both design and size the footings for the building. Next. As you can see, we utilized two different types of footings for the structure. One was a continuous spread footing, which was recommended by the geotechnical engineer who gave us the soils report. The purpose of this was to transfer the load from the building to the ground and was ultimately utilized along the exterior walls of the structure. The other type of footing we used was a pad footing, and we used this wherever columns were to be bearing on soil, and the ultimate goal of these was to transfer load from the overhang on the exterior of the structure to the ground. For the continuous spread footings, we utilized about 315 cubic feet of concrete, and for the pad footings, we utilized about 40 cubic feet of concrete. Next.
In designing the slab, we aim to come up with the appropriate thickness and reinforcement needed for the structure to hold the load. So we analyzed two systems, a structural force system, cross space, and a concrete slab on grade. And the question was which one would be more efficient in terms of functionality and economical in the long term. The team ended up adopting the concrete slab on grade. That was our final decision. Now, we analyzed the loads because the load is going to be like a very slow moving load. We realized it's going to be so high stress concentration at the edges. So we went ahead and increased the edges with by 2-inch thickness. Upon coming up with a design thickness of 7-inch for the concrete, with the reinforcement still is made of number 2 bars, 12-inch on center. Next. Then we went ahead and put together a specification on how to treat each material that is going to go into building the actual structure. And worth mentioning among those specifications are appropriate insulation that need to be added to the inside of the wall to protect the slab from extreme temperature. Thank you. Next.
So as you can see on the right-hand side of the screen, this is what the structure would look like when it was complete. Then if you were to look at this from an overhead view, like a bird's eye view, you would see what you have on the left-hand side as the floor plan or the framing plan used. Obviously, you can't see and read everything in this diagram. Its purpose is to be an example of what we have provided to the client as well as what's provided in the report. But in these diagrams, what you're going to get is dimensions, locations of where things are at, what type of material is being used, as well as section and detail cuts that give the person constructing the structure more information on how it's being built. Next.
My name is Jessica and I will be explaining the ISDS. The ISDS stands for Individual Septic Disposal System. It's also known as a septic disposal system, which is a method of disposing and treating household wastewater in areas where public services are not available, such as this one. Our ISDS was designed based on the following assumptions. No residential rooms in the proposed structure. It consists of only an office, storage, kitchen sink, bathroom with a shower. And a maximum of 5 people per day will be occupying the building. There's a treatment level 1 with the soil perk rate between 6 to 7 minutes per inch, which needs to be verified by performing the additional soil perk test, which is mentioned in our future work in the section of our report. So due to these parameters, the septic wastewater effluent input flow rates resulted in up to 343.5 gallons per day. And based on this rate, the total area that we need are 446 square feet, which the CDPHE only allows the maximum allowed length per of 150 feet. And so this turned out to be 2 trenches of 110 feet long. The pipe perforations and the leach field need to be at 5 o'clock and at 7 o'clock to avoid collecting of sludge. The slope is recommended to be 0.01, and the trench depth is 30 inches and the width is 24 inches. There needs to be a max soil cover over disposal field of 2 feet, and the drain field spacing needs to be 6 feet from center to center, which allows space for a set of replacement trenches to be placed between the original ones when the first set fails. The inside pipe diameter needs to be 4 inches minimum, and the capacity of the septic tank needs to be 1,000 gallons. And if you go to the next slide, there will be detail of the trench in the bottom and the pipe, and the pipe and the washed gravel needs to be covered with geotextile over around the area. And the trenches and pipes are recommended to run parallel to the contour lines, which it shows on there. But as my colleague mentioned, you're not going to be able to read all of this detail, so it is included in the report.
Our study for the project also included cost analysis. So we've come up with an estimated cost with a total of $27,500, and that includes the concrete, $7,600, the utilities, and that includes wastewater, electricity, electrical to be $12,500, and the building to be $63,000, and that including structuring the building. Our total also include the labor, which is 30% from the whole cost of the structure. Next, please.
So to get this building built, we have a proposed construction sequence without permitting. So just the build phase, we're proposing take about 16 weeks, starting from the ground and working all the way up through the roof and then going through the finishes. Including permitting, you can expect to add a month or 2 to that schedule. And ideally, since it's a 1-story building that's similar to residential construction, we're able to do it in this 16-week time frame. If there are problems, you could end up adding 4 to 8 weeks, but ideally, this 16-week Gantt chart should get you a finished product. And now we have a SketchUp video of our actual building. And that concludes our presentation for the structure at the Andrick Pond State Wildlife Area. Thank you.